All right, welcome to a nomenclature worksheet. I'm going to work through several of these and tell you which ones you actually don't need to name. Let's look at the first worksheet. You should have a periodic table in front of you and have already read the assigned reading for this week so that you know the list of steps involved in naming compounds. What I'm going to do is we're going to look through, let's say, 1 through 23, and we're going to identify all the compounds that are covalent compounds. Covalent compounds, and I'll write this right over here. Covalent compounds mean that there are two nonmetals involved, at least two. Nonmetals in the compound only. So that means there are no metals. Okay, in case you want a reminder of where to find nonmetals, nonmetals are in this area. Actually, I'll highlight it. This area right here. Okay, those that are in this green, this like weird looking green, those are called metalloids, and that's really the transition from the left-hand side to the right-hand side. From metals to nonmetals. So everything to the left of that, right here, excluding hydrogen, is a metal. Hydrogen is on a kind of a wacky side of the periodic table. It is a nonmetal. Okay, so with that in mind, let's look through. I'm just going to pick some random ones. Look through the list from 1 to 23 and identify where our covalent compounds are. So let's look at number 1, dinitrogen pentoxide. All right, let's identify what's actually involved in this compound. So I see nitrogen and I see oxide. So the nitrogen is the first element in that compound. Nitrogen is right here on the periodic table. It's on the right-hand side, so it's a nonmetal. And then oxide, the IDE ending is just because we dropped the ending in oxygen and add IDE for compounds. And so oxygen is also a nonmetal, so that means I have two nonmetals, so this is a covalent compound. So using that logic, I'm going to just put a little check mark next to the number of the ones that are covalent. So this is covalent, this is covalent, water is covalent, carbon dioxide, sulfur trioxide. 7 is ionic, because calcium's a metal. Lithium's a metal, strontium's a metal, aluminum's a metal, sodium, zinc, silver, barium, potassium, sodium perchlorate, silver acetate, ammonium oxalate. Ammonium is not a metal, but it is a cation. Okay, so I'm going to go over what that means when we look at ionic compounds. So that's also, 18 is also ionic. Ionic, 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 ionic. Okay, so I know the 6 at the top are covalent. So what I'm going to do is I'm going to put the formula next to it. I'll do it in blue. Okay, the prefix. I'm going to actually erase this. And then increase this size. And just look at the first 6. Okay, so the prefix tells you how many of each atom corresponds to that element. So di means 2, dinitrogen means I have N2, pentoxide, the pent means 5, so N2O5. So you need to know prefixes 1 to 10. All right, moving on, bromine pentafluoride. There's no prefix in front of bromine because there's only one of them. If the first element, there's only one atom of that element represented in the compound, then the prefix mono is left off. So that just is Br. And then pentafluoride, penta again is 5, and then this comes from fluorine. So you'd have that. So if you are unfamiliar with the symbols and their names, if I just blow this up, you'll see that bromine right here, the name is underneath the symbol. So if you weren't familiar with the atomic symbol for bromine, you could just look on the periodic table, and then the F for fluorine. So it's, again, a really good idea to have the periodic table next to you when you're naming these. Water, this is not a systematic name. This is actually a common name. So you don't need to worry really on quizzes and exams about common names. You just want to worry about systematic names. So the name for that would be dihydrogen monoxide, in case you were wondering. All right, carbon dioxide would be CO2, tetraphosphorus decoxide. Phosphorus is P, tetra means 4, so P 4. Dec oxide, so oxide is oxygen, dec means 10. All right, and last one in the series, sulfur trioxide. Sulfur, just one of them. There's no mono in front because there's only one for the first element, and then trioxide is oxygen, and there are 3 of them. Okay, let's move on to 7 to 23. So I'm looking in this area right here. These are all ionic compounds. Ion means charged, so that means you have 2 charged species. An ionic compound contains a metal, more broadly, a cation with an anion. When you think cat, think of the T, that means positive, and negative. Okay, so the first species, or the first name in the series, is a positively charged atom, and then the second name is a negatively charged atom. Almost always that means you have a metal and a nonmetal. So a really easy way to identify what type of compound you're looking at is to identify if the first one is a metal or nonmetal. So I'm going to do about 4 with you, and then I'm going to pause it, fill in the rest of the answers, and then leave it there for you to check. So let's look at number 7. So 7 is calcium, and this actually, it's even more important to have your periodic table when you're doing ionic compounds, because you need to identify the charges. So again, calcium. So let's identify where calcium is. Calcium's right here. So that first, what I'm going to do is I'm just going to write down the symbol for calcium, which is Ca, and then oxide comes from oxygen. So let's identify where oxygen is. So that gives me the symbol O. What you also have to take into consideration when you're writing the formula, this is the chemical formula, when you just use the symbols, that's the formula, is you have to take into consideration the charges. So how do I identify that in case the book didn't make it completely clear? For all main group elements, and those are the ones that I'm going to have you focus on. Main group elements are the ones that are right here and right here. So basically anything in the center, this rule that I'm talking about right now, or I'm going to state, does not apply. So for main group elements, the column that it is in is associated with its charge. So for instance, the first column means all of these metals right here, when in an ionic bond, will have a charge of +1. So I'm going to put that at the top. This is +1. The second column is +2. So using that rule right here, that tells you that calcium has a +2 charge. So just in the intermediary steps, I am going to put a 2+ above calcium to label it so that I can know how to write the subscripts associated with each of the atoms. Okay, next I have to identify what oxygen is. Okay, so oxygen is right here. You can kind of think of this as your home base. Okay, so think of this as, these are noble gases. This is the area that all atoms want to go. All of them want to be just like the noble gases, because every noble gas has a total of 8 valence electrons. That means that it has 8 electrons in its outer shell. Those are the ones that are responsible for bonding and really what makes elements what they are. Okay, so with that in mind, look at where our oxygen is. How many spaces or how many columns away is it from its nearest home base? Well, it's 2 spaces away. It needs to go to the right 2 spaces in order to be like neon. That means it needs to add 2 electrons, and that's what it does when it is an anion. So that means that oxygen has a 2- charge, and that is the same for all of the elements in this column. They will all have 2- charges. Now let's apply that same rule to, let's say, the column next to it. These are called the halogens. Well, they are 1 column away from their home base, so these have 1- charges. The same thing for nitrogen and phosphorus. They are 3 steps away, so they have 3- charges. Boron, I'm going to go over to boron right here. It's actually quicker for boron to go backwards and lose electrons, lose 1, 2, and then go all the way to helium. So it's going backwards. It's basically jumping back, and then to helium. It's easier to lose 3 electrons, so it has a 3+ charge. You're not really going to be assigning charges in this column for this class. So all you need to be worried about is the first 3 columns that has a 1+, 2+, and 3+ charge. And I really should be consistent with notation here. The best way to write this would be 1+, and 2+. Okay, it's the same. Okay, so a +1, a +2, a +3 charge, and then 3-, 2-, 1-. So we're going to apply that. So that means that oxygen has a 2- charge. Okay, when calcium and oxygen come together, 1 calcium and 1 oxygen, the charges balance each other out, so I just need 1 of each. So think of it as a magnet. If the magnet of calcium has a strength of 2 in the positive direction and oxygen has a strength of 2 in the negative direction, when they come together they cancel, so I just need 1 of each. Okay, so I'm going to erase those little numbers at the top. I don't know why this one won't erase. Let's see. There we go. Draw that. So that would be your formula. Let's do lithium iodide a little bit quicker. And then I'm going to write the answers until number 23 and then allow you to check it on your own. Okay, so lithium is in the first column right here, so it's a 1+ charge. So lithium, I'm just going to put a little plus next to it. And then iodide. Iodine is right here, and notice it has a 1- charge. So iodide minus, when they come together, they are equal and opposite in charge. So the final chemical formula then would just be Li, capital I. Okay, go ahead and pause this and work on numbers 9 through 23, and then I'll fill in my answers. Okay, here are answers that are pertinent to this class for 7 through 23. So we did 7 and 8 together. Let's just look at strontium fluoride, number 9, so that you know where I got that answer. So strontium has a 2+ charge. If I look over at the periodic table, it is right here. So it's in the second column, means it has a 2+ charge. Okay, let me put it back. And then fluorine has a 1- charge. So if you have 2 different numbers for the charges, that means that you need to manipulate something. You need to change the subscript so that the charges will balance, so the overall compound is neutral. So what you're going to do is you just switch the numbers. So strontium has a 2, you give it to fluorine, and then fluoride is a 1 minus, and you give it to strontium. So that's where you get Sr with a 1 in the subscript. You don't see the 1 because we omit 1s. And then there's a 2 for fluorine. So now the charges are balanced and it's a neutral compound. So I followed that rule all the way down. I X'd out the ones that really aren't necessary for you to know in this class. So go ahead and pause the video and change anything or modify anything that you need to modify. And then I'm going to go through the rest of this sheet and tell you which ones you actually should know and which you don't need to be worried about for the exam or quizzes. Okay, so if you look at the list on the right-hand side, those ones that are crossed out are unnecessary for you to know. The ones that are circled, I did not finish, so I expect you to finish them on your own. But there's something else I want to point out to you that I didn't specifically talk about, but it was mentioned in your reading. Let's look at number 26. There's actually 2 components here that I want to focus on. So the first is an additional feature here. You see the Roman numerals. So that Roman numerals apply when it's referring to an atom that's in the transition series. So remember when I was talking about main group elements on the left and the right? So anything in here is considered a transition element. In addition to, these aren't necessarily considered transition, but they do have varying charges. So the reason for this parentheses is in the number inside. It allows you to know the charge for that metal. So in this case, iron, that little Roman numeral 2 means it has a 2+ charge because it can change charges. It's funky like that. So again, if you are identifying or naming any metal that's in the transition series or that has a varied charge, you do have to use the Roman numerals next to it to indicate what the charge is. The second feature that I didn't specifically talk about yet is when you have what's called a polyatomic ion. So I'm going to focus on this right here. This is SO4. So SO4 by itself, when it's not next to a charge that balances it out, so in this case, that iron 2 is like the positive magnet and the sulfate is like the negative magnet. So when they're together, they're neutral. But if I just looked at sulfate by itself, sulfate has a 2- charge. Okay, this is called, like I said, a polyatomic ion. So it is just what the name implies. Poly means many, atomic, atoms, ion, it's charged. There are many atoms that are together and they're charged. I am not going to quiz or put on an exam any of these for you to memorize. When they're on this sheet though, if it is not referenced in your book, it's a really easy Google search. You'll just have to look them up and you'll have to be able to know how to balance the charges. So with that said, on a quiz and exam, I may give you a polyatomic ion and I'll tell you what the formula is. So let's say I said sulfate. I would tell you that sulfate is SO4 2-. You would just need to know how to balance the charges. So you know in this instance, just like we did in the previous example, iron with this little 2 and Roman numeral, that means it's 2+. Sulfate is 2-. So notice they're equal and opposite. So they cancel, they balance each other out. So I just need one of each of them in the chemical formula to have a full balanced compound. Okay, so I'm going to move periodic table off. So the rest of them again, if there are any polyatomic ions like carbonate, I'm going to underline it, carbonate, permanganate, bicarbonate, etc. Really easy Google search. You just need to know how to balance the charges. I don't expect you to memorize them. I just want you to know how to use them. All right, this is sheet 2. I've X'd out anything you don't need to do, and I want to explain another portion right here where it says stock. This just means that you're using Roman numerals. Okay, so just like I had explained on the previous sheet, It means you need to put Roman numerals next to the name so that we know what you're referring to or what charge the metal is in the name. So let me do a couple for you. Let's look at number 1. So when I'm naming compounds, I still have to determine if it's ionic or covalent. Let's look at the first one. I have nitrogen and oxygen. On the periodic table, you'll notice again that nitrogen and oxygen right here are nonmetals. So that means that this is a covalent compound. So when I name it with prefixes. Pull this up. I have 1 nitrogen, so I name this nitrogen. I have 2 oxygens, it's a dioxide. Let me do 23 for you. Okay, so 23. Cr stands for chromium. I'm not going to do the Roman numerals just yet. I'll leave a little placeholder for it. And Br is bromine. Drop the ending and add IDE. I have bromide. Okay, notice I have 3 of them. That means that chromine has a 3+ charge because bromide is a 1- charge. Remember, when I'm balancing the charges, I switch the charges to the subscript. And so that's where I get the 3. Let's do 25 also. Okay, because this one is a little bit nuanced. So CO stands for cobalt. Again, I'm going to just leave the parentheses blank in between. And then S stands for sulfur. I drop the ending and I put sulfide. Sulfur, if you look on the periodic table, is a 2- charge. Okay, that means that cobalt is a 2+ charge because there's 1 cobalt and 1 sulfur. Okay, so in order to balance it out, for these charges to balance out, cobalt has to be 2+ and sulfide has to be 2-. Okay, so that would be your answer here. So go ahead and pause the video. I'm going to put a couple more answers in here for you to check and to see if you're on the right page. All right, let's look at the ones that I have up. So number 1, nitrogen dioxide. Number 6, you have 2 nonmetals, so that's carbon monoxide. Number 7, you have a metal and a nonmetal, and I accidentally left off the E here. So that means you don't use prefixes. It's an ionic compound. You just name the 2 elements with "ide" at the end, so potassium iodide. 14 is an example of a metal or a cation and anion, and the anion is a polyatomic ion, so the C2O4 is named oxalate. That's something that you would just look up online, what C2O4 stands for, with a 2- charge. And 17, calcium carbonate. Number 31, mercury 2 nitrate. NO3 is also a polyatomic ion. So use this as a reference when you're finishing this worksheet, and then I'll go down to worksheet 3. All right, let's continue this with acids. So I'm on worksheet number 3. So this is going from name to formula. Nitric acid. Now I'm going to remind you of a mnemonic. So there's a mnemonic that says I ate something icky. And the second part of the mnemonic is Sprite is delicious. Okay, I'm going to highlight what's important about that. Ate and ick, ite and us. Okay, what that means is that if the ending of what's called an oxoacid is an IC, like this, that means the original name had an ATE ending. So let me give you an example of that. So nitric acid, the IC means that it came from the polyatomic ion nitrate, which is NO3-. So to finish the chemical formula, all I would need to do is balance the charge with a hydrogen in front, just 1 hydrogen, and that would make this a neutral compound. I'm going to erase that negative. I want the rest of that erased. Let's see. There we go. Erase that negative right there. So that would be your final answer for nitric acid, HNO3. Let's do the next one, hydrochloric acid. I'm going to blow this up a little bit. So notice the beginning of the name is hydro. I'm doing a different color. Hydro. Hydro in front of the name with acid means there's only 2 types of atoms in the formula. So that means the first one is hydrogen. Because it's an acid, there's always going to be an H in front. Chloric acid means that it came from chlorine. So your formula is HCl, and technically we do have to put a state of matter, which is AQ. Aqueous just means it's dissolved in water. So go ahead and pause the video, see if you can do a few of the other ones, and then play it again to see some of the answers. All right, here are some of the other answers. I left some off so that you could test yourself. They're very similar to the previous acids that we've named. So go ahead and follow that logic. And if you need to, you can Google these. These are on Google, but the whole purpose of this worksheet isn't just so that you would get it done, but so that you would have practice for the exam. So let's move down. Is this our last set, our last couple sets actually? Let's look at giving the names to a few of these. We'll just work on 1 through 7 right now. All right, so HNO3, we actually already named that above, but remember what you're looking at for those that have a polyatomic ion is the name of the polyatomic ion, which is nitrate. When it is an acid, that 8 becomes an IC, and then you add acid. So your final name for this would be nitric acid. All right, let's do HBr. So there should be an AQ next to this, next to anything that just has 2 types of atoms. Here's another example. So if I see just 2 types of atoms and there's an H in front, that means it's an acid. And the first part of the name is hydro. So hydro, now I'm going to name the bromine that is connected to it. Drop the ending and add IC, so hydrobromic acid. Let's just do one more. Let's do HNO2. So NO2 comes from the polyatomic ion called nitrite. Oops, not nitride, but nitrite. Okay, ite, based on the mnemonic, becomes us. And then I add acid to name it as an acid. So my final name would be nitrous acid. Okay, go ahead and pause the video. I'm going to name the next set and then check your answers. All right, here's some of the answers for 8 through 14. I crossed off 15. It's a little bit nuanced, so you don't need to worry about it. But check your answers for 8 through 14, or simply write them down. So if you've had enough practice in the acid area and you just want to finish the worksheet, that's also fine. So we're going to move on to our last couple sections. Organic chemistry, this is all by memorization. I don't need you to memorize all of these. I just want you to be familiar with the fact that organic compounds consist of carbons and hydrogens. And all of the what are called straight chain alkanes, it just means that everything's singly bonded together. All of the simplest organic compounds, the ones that you want to be at least vaguely familiar with, are those with 1 to 10 carbons. And those are the ones that are represented here. So again, there's not a systematic naming approach to these particular compounds. It's just memorization. You do not need to memorize these, though, for a quiz or exam. You just need to be familiar with the fact that organic compounds are hydrocarbons, which means they just contain carbon and hydrogen in this case. So I'm going to leave that for you to look up, and then we're going to move on to the nomenclature worksheet 5. So there is nothing new in this on this sheet. There's no new naming system. It's pretty much taking most of what we're naming and putting it together. and seeing if you can distinguish between certain types of compounds, how to name acids, how to name ionic compounds, and how to name covalent. So I'm going to circle the ones that I'm going to do and X out the ones that you don't need to be familiar with. I'm going to do number 1. I'm going to do number 6. You don't need to do number 7. I'm going to do number 11. I will also do number 17 and number 18, and then I'll do 44. You don't need to be worried about 41 or 42. I'll do 39. You don't need to be worried about 35. I'll do 33. You don't need to be worried about 30. And I'll also do 27. Let's see if there's anything else that you don't need to be worried about 34 either. I'm checking to see if there's anything else that I want to cross out. I think that's it. So go ahead and pause, do the ones that are circled, and then come back and check. All right, go ahead and take a look at the ones that are circled and done. The ones that aren't, you'll need to finish by yourself. There are a few more just underneath this. And the ones underneath, I will cross out the ones you don't need to do. You don't need to do 45. You do not need to do 19 or 21 or 22 or 23 or 50 or 47. All the other ones finish on your own. Let me know if you have any questions as usual, and good luck on finishing this assignment.